AgResearch scientists are developing new generation forage legumes for better capture of nitrate and phosphate that might otherwise be lost to waterways. The hybrid pasture plants would also have greater access to subsoil moisture, which would improve their drought tolerance. Dr. Jim Crush explains.
The root research is really driven by the fact that the whole history of forage plant breeding in this country has been based on above ground characteristics of plants, simply because that's what animals eat, fair enough. But we know if we're going to develop truly sustainable farm production systems, we need improved nutrient efficiency, and that means you need better root system, better root function. The principal issues really are the input costs of fertiliser to farmers. They are very significant, particularly for sheep beef farmers, but also in dairying. And then there's the environmental cost of running high nutrient input systems with loss of surplus nutrient basically to surface water and negative impacts on water quality. That's emerging as a real issue in New Zealand. The Clover program, the real driver there is phosphate efficiency, and we have screened extensively within white clover looking for variation in root morphology, that's root system shape. Phosphate only moves extremely slowly in the soil, and so the New Zealand strategy has been take phosphate to the clover root by putting on lots of phosphate. We're turning that round, and our strategy is to take the clover root to the existing phosphate in the soil. So we have been screening for clover plants with very finely divided root systems that explore a large volume of soil per unit root length. As we started to work with deeper rooted selections of plants, which we thought would be useful to intercept nitrate, we began to think more widely about deep rooting and drought tolerance, possibility of carbon sequestration in the subsoil being a potential additional revenue source for farmers. What we've got here is a white clover, a commercial cultivar. It's growing in a soil that's got a phosphate test pretty much typical of hill sheep and beef farms. The one on the right, it's the same soil, same phosphate level, but it's one of our new interspecific hybrid clovers. It's a hybrid between white clover and this Mediterranean clover, Trifolium uniflorum. The hybrids certainly do get their roots down. In our standard tests, they'll grow roots down to 1 metre quite comfortably. This is the same material that we've seen growing in soil in the other glasshouse. We put the material into hydroponic culture because it means that we can access the root system and do controlled experiments on intact root systems. This is a standard New Zealand white clover cultivar bred for hill country farming, and you can see it has a reasonable root system on it, but the same material crossed with Trifolium uniflorum, you can see much deeper root system on the hybrid material, and we think this additional root length will be very valuable, not only scavenging for phosphate, but also accessing moisture a little bit deeper in the soil. So perhaps a degree of drought tolerance. White clover's ability to access soil phosphate is really weak. It competes very, very poorly with ryegrass for any applied fertiliser. And in our systems, you have to apply 3 times the rate of phosphate to grow a grass clover sward than if you grew the clover on its own. The end point of the program, our vision, is for new generation forage legumes that look and perform like white clover above ground, but with a much reduced requirement for phosphate fertiliser and hopefully improved moisture stress tolerance as well.
This program was made with funding from New Zealand On Air.